Find in terms of log base 2, 3 an exact solution for the equation. Exact means you have to leave it either in square root or in as a fraction. So this is what they mean by exact. Don't give them a decimal when they say exact, remember? So you start. First thing, you have to decompose any number that you can. So 8 is decomposed into 2 to the 3, and you already have the value, the 8 is to the exponent x, so it's going to be 2 to the 3x. Now you start solving for the value. So you take this and divide it like that, because 2, 3 to the x divided by 2, okay. If I have 3a equals to 4, how am I going to find a? It's 4 over 3. So instead of all of this complicated manner, you just say 3a equals to 2. So 3 is equal to 2 over a. Why did I take the 2? I didn't take the 3 under the 2 here, because I want to use the formula which, or the rule which says a to the m over a to the n is equal to a m minus n. So since I have same base here, I can use it. So I can say that 2 to the 3x minus x minus 2 is 2 to the 3x minus x plus 2. It's 2 to the 2x plus 2. So this is the first step that you should be careful and that you should pay attention to it. You take the same base and divide them. This is why I kept the 3 and divided by the same base. Now, we didn't solve for x, by the way. Until now, we didn't solve for x. So now my equation became 3 equals 2 to x plus 2. So in order to find or to solve for x, you need to log, so that this will become, it's not an exponent anymore. So you log both sides by log 2 to the 3, by log base 2. Because this is what they want. They want you to find in terms of log base 2, 3, of 3. So you log both sides. After you log both sides, you use the exponent rule. And this is what happened here. And then you have log base 2 of 2 is 1. And then you use the 7 rule, which is 2. So far, okay. So here you're going to have, you don't use the 7 rule. You take this to the other side. So you're going to have 2x. You take the 2 to the other side, and then you divide by x, and you're going to have, you divide by 2, and you're going to have this answer. This is what they mean by the exact value. You don't find the answer. You just write it in terms of log base 2 of 3. Now, in order for me to clarify what happened here, I'm going to write it. Log base 2 of 3 is equal to 2x plus 2. Since we want to find x in terms of log base 2 of 3, as they said in the question, you just move this to the other side. So you're going to have 2x is equal log base 2 of 3 minus 2. Now I need to divide by 2 because I want to find x. So you divide by 2 everything. Log base 2 of 3 minus 2 over 2. So now if you have a minus b over 7, it's a over 7 minus b over 7. This is what I did. Log base 2 of 3, 2, minus 2 over 2, which here is 1. Now you're going to tell me, should we divide it like that? Yes, because you have to write it in the simplified form. Questions?
Miss, could you repeat this part? Like the log base 2, 3 is equal to 2x plus 2, log base 2 to the power of 2. Like that part, I didn't.
Okay. Let me start from the beginning there. So you log both sides. So here you have 3 equals to 2, 2x plus 2. I need to get x as a number, not as an exponent. So I need to log both sides. And since they said you have to have the answer in this form, in the answer you have log base 2 of 3. So in terms, yani in the final answer, you have to have log base 2 of 3. So you log both sides, log base 2 of 3 and log base 2 of 2. Now using the exponent form, you're going to have log base 2 of 3 equals to 2x plus 2 log base 2 of 2, like that. Now log base 2 of 2 is 1, because this is a rule. Log of base a of a is 1. So now you're left with log base 2 of 3 equals to 2x plus 2. Now I'm solving for x, so I should remove everything to the other side and keep x on one side, and that's it. Is it clearer now? In double I, solve using algebra the equation. So now you have to solve this equation, explaining clearly why there is only one solution. So you start doing the solving. So this is what you need to solve. So we start with the rules. So you have to know the rules, okay? You have to know the rules. They will not give it to you in the formula sheet. Let me go back to the formula sheet. With respect to log, they will only give you this, which is the changing of the base. Other than that, you should know all of the other laws of log, okay? So going back to our example of number, okay, so you start. Take the 2 as an exponent, and you have to take this to the other side, and I need someone to tell me where the 1 disappeared. Any idea? Where did the 1 disappear?
Yes.
Where is the 1?
It changes to log 5 over 5. Log 5 to the power to the 5.
So
because
yeah.
Because log a of a is 1.
That's right. So why did we change the 1 into log base 5 of 5? Because I need to reach a phase where I can remove the log from both sides and I can solve for y. So I changed 1 into log base 5 of 5. So that's it here. And then since I have addition and I have the same base for the log, I multiply 5 times 2 minus y. So now I have log base 5 on both sides. I can remove, and I'm left with the y alone. Now from there onwards, it's algebra. you expand, and you take everything to one side, and you're left with this equation. Now, this equation is a quadratic equation. You can either use the delta, or you can use your calculator, or you can use what I did here, sum and product. So factoring it, you will get the solution for y 3/4 and y equals -3. We reject the negative because you can't have it, you can't have y as a negative number. So we accept only the positive number.